I'm Anil Kumar, and here is solution of question number 16, page 574 from Advanced Functions Nelson. Now this question is being shared with my student Maria. Maria, I hope this solution helps you to understand the concept, and thanks for sharing this question. It will also help you in the final exam for advanced functions. You will learn the technique of writing equation for a polynomial. Let's go through the question. The number 1, 4, 10, 20 and 30 are called tetrahedral numbers because they are related to a four-sided shape called a tetrahedron. Determine a mathematical model that you can use to generate the nth tetrahedral number. So in this case, we are given a couple of numbers which form a series, and these numbers are 1, 4, 10, 20 and 35. I think this is a wrong number. The number should have been 35. Okay, so these are the numbers given to you, and you have to write a general expression which can represent this series. Okay, and this series is called tetrahedral number series. Whenever you are given sequence of numbers like this, you need to find finite difference. If you find finite difference, then you will know the degree of polynomial, which can help you get the equation. Let's find the first finite difference. Now first finite difference I'll denote by delta 1, first finite difference. That means 4 minus 1, and in this case it is 3. 10 minus 4 is 6. 20 minus 10 is 10. 35 minus 20 is 15, right? So what we did was difference between the consecutive terms, right? So basically we did y2 minus y1 to find the finite difference, and that is delta for us. So this first time when we did, we get numbers 3, 6, 10, 15. Well, they are not constant, so it is not a linear function. Let's find the second finite difference. So let's say delta 2. So second will be 6 minus 3, 10 minus 6, 15 minus 10. 6 minus 3 is 3, 10 minus 6 is 4, and then we have 5. This is also not constant, and therefore we can say that it is not parabola, right? It's not quadratic. But let's figure out the third finite difference, delta 3. 4 minus 3 is 1, 5 minus 4 is 1. If you continue the series, that is constant. So what we figured out here is that the third finite difference is constant, right? So third finite difference, let me write delta for difference, is equals to 1. That is constant. Now if that is the case, then what type of equation do we expect? So it means it's a polynomial, right, of degree 3, right, of degree 3. Now that is one thing. So in general, this polynomial could be written as f of x equals to ax cubed plus bx square plus cx plus d. So that is the general equation of a polynomial of degree 3. Now we need to find equation of this polynomial, which in itself is a big job, right, given these values. So first thing what we will do here is that we will assume that the series really starts from 1, 4, 10 and so on. So if I put x equals to 0, I should not get any number, right? So basically we say for f of 0, I am expecting 0. So if I put 0 here, then d should be 0, right? So that implies d equals to 0. Now, so I am assuming that my function will have only these three terms. D should be 0. Since for 0th term, for x equals to 0, I do not have any term in my series, right? It's fair enough logic. Now, how does this finite difference help us to find leading coefficient? Can you tell me that? If you remember the formula, the finite difference and leading coefficient are related. A, let me write down here the formula. A equals to the finite difference, which is, we'll say delta n. In our case it was third finite difference, over n factorial. So that gives you the leading coefficient's value. In our case we found that the third finite difference was constant. N factorial means 3 factorial, right? So we can write down the value of a as the constant finite difference, which is 1, divided by 3 factorial means 3 times 2 times 1, which is 1 over 6, right? So we get our function as f of x equals to 1 over 6 x cubed plus bx squared plus cx. You get the point. So we have substituted d as 0, a as 1 over 6, and that's a very standard formula which you can always apply for any polynomial. Okay. So once you find the third finite difference is constant, then the constant finite difference divided by n factorial, which is 3 in our case, gives you the value of leading coefficient a. Now we need to find the value of b and c. To find value of b and c, we need two equations, right? So what can we do? Now these are our terms, right? So basically what we have here is these are the terms, and let me write down the term numbers here, right? So the x values, what I'm trying to say, these are the y values, right? These are f of x. What is x? In this case x is 1, in this case x is 2, then we have x is 3, 4, 5, and so on, right? First number is 1, second is 4, third is 10, right? Fourth and fifth are 20 and 35. So what we can do is, to find the value of b and c, we have to use 2 points. So let us use first 1, 1 and then 2, 4. Okay. So we will use 1, 1 first. So what is f of 1 equals to? F of 1 is 1. So we'll write f of 1 as equals to 1. We'll write later. But substitute x as 1. So we get 1 over 6, 1 cube, which is 1, plus, let me write 1 here, 1 cube, plus b times 1 square, plus c times 1. That should be equals to 1, correct? So that gives us an equation, 1 over 6 plus b plus c equals to 1, or we can say b plus c is equals to 1 minus 1 over 6. That is 6 minus 1, or 5 over 6, correct? So we'll say, let this be equation number 1 for us. Okay. Now let us find another equation that we can find using the second point, right? So we used 1 point and got 1 equation. So we applied this point, right? So we got 1 equation. Now we'll use the second point to get the second equation. So let us write on f of 2 equals to what? So we'll say f of 2 equals to, replace x with 2, right? So a is 1 over 6, 2 cube, which is 8, right? Plus b times 2 square, which is 4, plus c times 2, right? F of 2 we know is 4, right? 4. So we can write this as 4 equals to 1 over 6 times 8 plus 2 square is 4, 4b plus 2c. Perfect. We can take this to the left side, so it is 4 minus 8 over 6 is 4 over 3, right? So we can write this as 4 over 3 equals to 4b plus 2c, plus 2c, right? So that is how we get our equation. 4 over 3, let me write down again, 12 minus 3 is 8, right? So we get 8 over 3 equals to 4b plus 2c, right? So I'm running out of space, but I have a lot of space on the left side. So let me use this place. Correct. So let's move from right to left. So this equation we could simplify dividing by 2, right? So we get 8 over 6 equals to 2b plus c. You get the point, right? So what we did here was we took 2 common, correct? Divided everything by 2 and then got it here. So we have moved from this place to that place. Okay. So we'll call this as our equation number 2. We already have one equation, which is b plus c equals to 5 over 6, right? So that was our equation number 1. Okay. Now you have 2 variables and 2 equations. So if I do equation 2 minus equation 1, if I do equation 2 minus equation 1, what do I get? I get 8 over 6 minus 5 over 6 is equals to 2b minus b, right, which is b. C minus c is 0. So I get b value, which is this. And that is 8 minus 5 is 3, right? So I get 3 over 6 as b, and 3 over 6 is half. So we get the value of b as half, correct? B is half for us. Now we can find what c is. From equation c, we can, let me change the ink also. Substitute this half value for b here, right? So we get c equals to 5 over 6 minus half, right? So that is 5 minus, we'll multiply both by 3 over 2, right? So which is 2 over 2 as, so that is to be 3 times. So we get, sorry, b is half for us, 5 over 6 minus half. So 5 minus 3, the denominator is 6. 5 minus 3 is 2, so we get 2 over 6, or c is equals to 1 over 3, correct? So we get the value of c also. Since we know now a, b and c, we can write down our equation. So let me write down the final answer. F of x equals to 1 over 6x cubed, 6x cubed, plus b is half over half x squared, plus c, which is 1 over 3x, correct? So that becomes the equation for the given function or the series, correct? So that's our answer. So our answer here is, let me write down clearly here, f of x equals to 1 over 6x cubed, plus 1 over 2x squared, that's the value here, and plus 1 over 3x, right? So that is how we get the solution of this particular equation. Go through these steps, and I hope that should be very clear. So we are given the number series 1, 4, 10, 20 and 35. Make this correction. Find the finite difference. Third finite difference is constant. So it's a cubic equation. So in the cubic equation we can find a by 1 divided by 3 factorial. That gives us 1 over 6. Substitute that. Take 2 other points so that you can find b and c by substitution and elimination. And then you can write down your answer, right? I hope that helps. Thank you and all the best.